Hello everybody, and thank you so much for joining us here at ObservabilityCon 2021 for our presentation on learning the tricks of Loki, distributed logging at scale. Before we dive into the presentation, a bit more about ourselves.
Hi there, my name is Urlichs Jones. I'm a principal engineer here at Civo Cloud. I'm also the tech lead for the CNCF group called Application Delivery, and I help to maintain projects, perform due diligence, and to help folks get into the sandbox.
My name is Anaïs. I'm a site reliability engineer at Sievo. Before joining Sievo, I worked for several years as developer advocate, first in the blockchain space and then in the cloud native ecosystem. I'm also a CNCF ambassador. Now, within our presentation, when we're talking about our learnings and our use of Loki, what are we actually basing our experience on? We both work at Civo. Now, what is Civo? Civo is a Kubernetes service provider, meaning you can launch Kubernetes clusters in 90 seconds or less. It's based on a Kubernetes distribution called K3s. We have highly transparent pricing that is competitive across the market, and we are cloud native first, meaning when you spin up your Kubernetes cluster, you can select the cloud native projects and tools that you want to spin up on your cluster alongside it. So within 90 seconds, you can have a Kubernetes cluster with your entire observability stack already running on top of it. Now, this slide is taken from our KubeCon presentation that we just had a few weeks ago. We have in several regions our stack, our compute stack, and on those stack, there are 32 compute nodes, of which 4 are the control plane. And on the rest, we run our workloads. So all of our tenant clusters are basically running within a super cluster. Now, as you can imagine, running this highly dynamic infrastructure, we need a lot of different observability tools installed to actually know what's going on in those different regions on those different compute nodes. Now, here's a little bit more on our agenda on how we structured our presentation. First, we will give a little bit of an overview to what Loki is, what is the infrastructure, and what are the different components that we need to use alongside Loki. Then we have a demo for you on how you can get started with Loki. And then we provide an overview of the tricks of Loki based on the past months of us using Loki at scale. So why do we want to use Loki in the first place? Well, traditional logging solutions are no longer fit for purpose. With our infrastructure and our application deployment getting more complex and more distributed, we need our logging solution, our entire observability stack to scale up with our needs. However, traditional logging solutions are first of all expensive. They don't integrate often with our existing observability stack. They are difficult to operate at scale, meaning they are difficult to operate in a distributed environment. And then lastly, they are challenging to correlate against your existing metrics. If they don't integrate in your existing observability stack, you will have to make the connection manually a lot of times. So here's where Loki comes in. Ultimately, our goal is that we want to use a cost-effective way to collect, store, and query our logs. Now, Loki is a highly available, horizontally scalable, multi-tenant log aggregation system. Now, you don't have to remember anything of those words in the slide, just that Loki equals log aggregation for you to store, access, and manage those logs. The benefits of Loki is that it's cost-effective. It integrates into your existing tooling and your existing observability stack. So, for example, if you're already using Grafana Cloud, you can just use Loki alongside it. Also, it scales with your existing infrastructure. You can run Loki either as a single binary in a distributed environment or as part of Grafana Cloud. Now, here's a high-level overview on what actually happens. What's the process between your logs getting generated and then you accessing those logs in your Grafana dashboards? Well, there's an additional component. In our case, we use Prometheus to access those logs, to basically gather those logs from, for example, from within your Kubernetes cluster. So wherever Prometheus runs, it will scrape those logs and gather them and forward them over to Loki, and then you can access those logs within Grafana. Now, you can use, instead of Prometheus, you can use also other tools, other components instead of Prometheus. We use Prometheus at Civo, so that's why our presentation will focus on Prometheus specifically. Now, a bit more about Prometheus. Prometheus is the part that is used to discover logs, process logs and ship those process logs to Loki. You basically set scrape targets for Prometheus of where it's supposed to get the logs from. It's highly similar to how you would set scrape targets for Prometheus. Here's a more detailed overview of our different components. So we have Prometheus running within our different clusters, within our different environments. Now, the Prometheus will gather those logs that are generated either from our infrastructure or our application, and then forward those logs to a component called the distributor. The distributor, the ingester, the query, and the query frontend are all part of our Loki stack. Now, the query frontend is optional. Once we have those logs and we send them over to the distributor is then responsible to make sure that those logs are actually valid, that they fit our requirements that we set up. Now, then the distributor will send those logs to usually three different ingesters. And the ingester is responsible to pack up those logs into chunks. Now, once either the chunks are full, meaning they reach the maximum number of logs that they can hold, or a certain amount of time has passed without the ingester receiving any logs, or it hitting a specific timeline, it will send those logs over to our long-term storage solution, whether that's in S3 bucket, DynamoDB, or another solution that we are using, that we're integrating with. Now, the good thing is about these chunks that they basically allow us to only store the minimum amount of information needed from those logs. So for instance, we don't store, or Loki doesn't gather the timestamp of every log, but only the timestamp of the first log in the chunk and the last one. And then within the chunk, all the logs are ordered by timeline of when they were received. And that allows Loki to query the specific time frame of the logs later on without actually needing access to the specific timestamp. Now, when we want to query our logs, we use the querier, and the querier is used to access the Loki API. The querier will pull out the logs either from the ingester, if they are still an ingester, or our long-term storage solution, and then make them accessible to the query frontend. The query frontend is optional. It can be used to optimize your use of Loki, but you don't have to use it.
How do we use Loki? Well, I'd like to show you a little bit more about how Sievo has implemented Loki in this simplified diagram. As Anaïs mentioned prior to this, we heavily depend on Prometheus for retrieving our scrape targets. And one of the things that we do that I think is fairly interesting is because we run bare metal superclusters, we have access to a lot of the journal and underlying logs that are particularly interesting, whether that's from the kubelet, whether that's from CAdvisor or some other service. And so therefore we use syslog-ng to forward the logs into Prometheus in the same manner as we would pull logs from the container path on the host from Kubernetes. This means that Prometheus is aggregating not only the system logs, but also the application logs. And as Anaïs took us through a moment ago, we push that through the distributed gateway, the ingester, and object store. One of the things that I will come to talk about a little bit later is some of the optimizations around this. But the exciting part for us is that we have a single pane of glass for our SRE experience where we can combine not only our log experience, but also our tracing and our metrics. Now I'd like to take you through a demo on a simplified example of Loki, where hopefully we can talk through the fundamentals of Prometheus, Loki, and Grafana within a Civo cluster. So now it's time to jump into the demo. The first thing I'm going to do is spin up a cluster. We're going to take a look at the code while this cluster is starting up. This is a Civo cluster. Should take about 1:40, 1:50 to start up. I've got a simple repository, which I'll share in the links that accompany the slides. What's effectively happening here is we have a very simple set of commands of create myself a new cluster and install the necessary stack to run on top of that. You can see here that we have Grafana, Prometheus, and Loki in a distributed manner being set up. And the last thing I'm doing is grabbing the secret out of Grafana. There's no more secret source. And I think you'll be suitably impressed that when we get this set up, it just works. I have two resources in terms of a config map and a prom values file. And to talk you through each one, the config map is simply so that Grafana knows where Loki lives in the cluster. And you can see it's a single line telling it that Loki lives at this service address. And secondarily to that, we have a Prometheus file And all this has inside of it is where's the gateway for Prometheus to push to Loki. So when we think about this sort of stuff, I think it's important to visualize it. What we're going to try and set up today is effectively a Civo cluster, which is a K3s cluster. In this cluster, we're going to set up an observability namespace. And in that observability namespace, we have 3 distinct components that are going to work together to provide us cluster level logging. So we have Prometheus, which will be installed as a daemon set. We have Grafana, which will be installed as a deployment. And we're doing the full Loki distributed architecture, which will give us the 4 or 5 named components from previously in the slide. So we'll have key features such as the querier, the distributor, the ingester, etc. So let's now go ahead and install this stuff. So you can see the clusters come up in 1:40 seconds. And now what's exciting is we're starting to install things into this cluster. I showed you in the illustration before that we have 2 YAML files. And those YAML files are simply for telling things where everything is. So if I was to describe it like this, you would effectively have 2 arrows, one from Grafana down to point where the Loki is, and one from Prometheus to say where it should forward to Loki. The kind of data we're going to show in this example here is going to be fairly straightforward. Each Civo cluster has what is called a Civo CSI controller. Now, the CSI controller is an interesting project because it will often throw some interesting debug messages whilst it's spinning up. And so what we can do is we can focus on those kind of messages. Secondarily, in your own clusters, what you might find is a useful thing to take a look at when you've installed Loki for the first time is the kubesystem namespace. Because in kubesystem, that's where you get to see a lot of these components working together. You can also see errors in the kubesystem namespace when you've installed something, it's not quite worked, if a pod has gone down or a pod is spinning up at the same time. So let's slide over to the next screen here and take a look at what's going on in our cluster. First things first is I described that you can see Grafana is being installed. The only thing I've had to do in this installation is to turn on my data sources sidecar. What that's done is it's enabled me to give it the config map, and the config map that's described where this Loki deployment is being read. That's it, really. So it knows where to get that Loki address from. And we do this in our superclusters in the same way. We actually try and do as much of this as in code rather than any kind of hand tailoring or hand cranking. And this is thanks to a lot of the work that's gone into making the CRDs within Grafana native so that you don't have to have any of that within the UX. Particularly at large scale organizations, when you might have hundreds of alerts, those can all now be codified in config maps as either Grafana data sources, Grafana dashboards, alerts, or additional config. So when we start to have a look at this, let's open up a new tab, and I'll show you just how easy it is for us to go into the code base from Sievo. So I have my simple makefile. I'm going to jump into my cluster, and let's see what's going on. As we grab our config, let's check our nodes. That's the first thing we usually check. So we can see I've got our cluster running. And what we should see on our cluster is that we have our various components installing. You can see Grafana is installed. I will just go ahead and do an installation on Loki so we can see how it works. We'll get Prometheus installed. I think this is more interactive. I can do it this way. So you can see Prometheus now installing. When Prometheus is installed, we can then put Loki in. And you can see here, we've got Prometheus successfully creating the pods. Once those pods go live, you can see that we can put Loki in place. Now it's the last command, Helm upgrade install Loki. So this is nice that you can see that this is exactly how we'd run it in our production clusters. We might have a little bit more config, but ultimately it's something along these lines. So I've now got all of my components installed. As you can see at the bottom here, this is a list of the things that are going into that Loki set of concerns. So everything's now spun up on the cluster. As I mentioned in the Grafana config maps, we have that data sources, and this is just for me to sidestep having to set it up manually. Comes out of the box. So let's take a look at things. I think we're pretty much there. I'm going to grab the password for Grafana, and I'm going to open it up in the browser. I'm going to port forward. This is a very helpful thing to do. Let's grab that. I'm going to put in my admin password. I've logged in. Now, what you should be able to see is that the data source is pre-configured. And this is fantastic. And one thing that's also worth mentioning at this point is that you can use the derived fields annotation to create links from the values of messages. And this is really useful because we can start to pull out fields that are nested inside of JSON structures and other objects. So that's pretty straightforward. We've got our data sources from Loki. Now, what you can see is that Loki in the Explore is set up. Now, this tab here already is giving me the option. You can see that labels have been pulled out of log messages that are being sent through the cluster. Now, I mentioned that Sievo job, didn't I? I mentioned the CSI controller. So we can see here that CSI controller, and I can show logs from my CSI controller. I can see that there's some debug messages, some interesting stuff that's happened. You can see that there's some gRPC setup configuration. Now, again, if I want to look at some of the more interesting stuff, I could say, well, what about errors, right? What's happened here? I wouldn't really anticipate any errors at this point in time. So we could pick something that might throw a few more errors, like the kube system namespace. There are always typically a couple of errors when Kubernetes is setting up, whether that's a metric not being sent or it's waiting for something else. So, equally, it's super easy for me to just do a check on error. However, more realistically, what could be useful is for me to look at errors over time to see, is my cluster getting worse or is it getting better? So let's run that query. And we can see that we're getting effectively data back from a few of these different apps. So I could even wrap this in an average. And that average would then tell me, hey, what's going on over time? So that could be a cool thing to show. So what we can do is we can do an average of errors over time. And I'll put the average on the wrong side. I'm sorry about that. There we go. And we can put that there. And we can see the average number of errors over time. And you can see how much effort I put into this, right? This is a couple minutes. And already, this is kind of useful. The XY might need to be tuned, but I can take this right here. I can make a new dashboard. And within 10 minutes, I'm adding value to my team because I can show them, hey, I'm getting data from our logs that show the average number of errors in our logs are increasing over time. And as I said, within a few minutes, I can save this as a very basic example, and we can have that up on our screen in the office, driven by logs from Loki. I hope that this demo has showed you that effectively you can get going with the bare bones of this makefile, right? You need Grafana, Loki, Prometheus, and you're already able to pull out value. And as an SRE leader and somebody that works with this stuff every day, it's absolutely invaluable. Let's talk about the tricks of Loki. And these are our collective experiences from working with Loki at Civo over the past few months. First and foremost, Loki can be configured to suit your infrastructure needs. It's flexible and scalable, and there are multiple components that can be dropped in and pulled out as need be. As you can see on this slide, I've assimilated this into three primary pillars. You have scaling. So the distributor component, as we know from the earlier slide, can be scaled out. Query front end can be scaled out as well, if need be, to have more pods to return requests. And equally, the querier can be scaled out. It's also important to know that when you are scaling these components out, you also have the ability to add additional caching layers. And memcache being supported is incredibly useful, especially when you're performing very, very repetitive queries that otherwise would be incurring a latency penalty every single time you query them. And an example of this might be if you build a dashboard from your logs and are using an expression on that log so that you can find some information to show the team, that would actually be hitting the querier multiple times. Whereas if we're using the caching mechanism, that actually will sidestep and get the cached result. The third piece that is particularly useful for us is being able to change the KV store. So we have the index store, but we also have KV stores, both of which have a variety of options. I've listed a few here that are particularly useful for our environment, which is native S3, using GCS, or even Cassandra as your backing store. And these options provide a lot of flexibility on where you ship your logs. For example, if you're an on-premises solution, you might want to use Cassandra because you can stand that up yourself and you won't incur transfer fees. Combining Loki with Tempo to extract traces from your logs is one of the most powerful and exciting features that we have the ability to leverage in our observability stack. What's so exciting about this is that you can pull out trace IDs from your logs, and in the Explore, for Tempo, you can see them right there and have a side-by-side view. I mentioned earlier this idea of a single pane of glass. Well, it's really epitomized by being able to work with these two different types of tools within Grafana and interchangeably pull out the data that you need. And this is a super exciting experience as an SRE. Labels are powerful shortcuts to your logs. If you're writing structured logging solutions and you have a standard set of labels and fields, you can really gain the benefit of seeing these within Loki by being able to quickly drag and drop into those labels to find out the information you need. As you can see in this example, if I want to see what's going on in Civo's CSI controller, I know that the app label exists and we've labeled that in the manifest for that controller, and we can pull that straight out. And that's a batteries included solution. We've not really had to do much additional work there to make that happen. What I particularly like as well is that we can then pipe it into a particular type of stream output. So we have a choice of looking at the standard output, the standard error, or the combined stream. And this, again, is particularly useful when you're starting to make dashboards, you're starting to leverage some of the next features that I'll talk about in Loki. LogQL. I touched upon the idea of looking into your logs, but LogQL syntax, very closely following PromQL, takes your querying to the next level. The built-in functions that come with PromQL and LogQL are very similar. So averaging, rate, and other commands are all there for you to use. In this example, you can see I took that CSI controller error rate and I've started to look at it over time. And this is extremely exciting because you can start to build out dashboards. You can start to pull out useful information directly from your logs. And this is something that was an extremely tedious task, or had to require a lot of chaining of filters and expressions. And it's done in this extremely concise and succinct way. And probably the last but the most impactful tip that I have for Loki is that you can use Loki to create dashboards. And I've mentioned this a few times now, but you only start to understand the power of what you can do when you start using the explore feature, taking an expression, putting that into a dashboard. You are effectively falling into a pit of success. And as you can see from this example, this has come from one of our test clusters. It is extremely powerful to see how many errors you're getting across the board. Now, this is a broad net, but it's a signal that's useful because you can start to see that if the errors spike from 0.1 to 43%, you know you've got a problem. And as you can see in the live logs there, it is so easy to find out where that's coming from. And again, if you're leveraging other tools like Tempo, or if you're combining Prometheus metrics into your Grafana solution, you have a one-stop shop for being able to start to diagnose, triage, and remediate these issues. So what's next for Sievo? What are we doing with our observability stack? Where are we taking our solutions in the future? Well, it comes down to three primary tasks for us to achieve by the end of 2021. Inter-regional logging is a big next step for us. We've got fantastic logging at the supercluster level with Loki. We're going to take that further and start to use Promtail across our regions to aggregate logs from Frankfurt, from New York, from London. We want to be able to see that if we apply an update to a supercluster control plane and there's a different version of Kubernetes, is that reflected in the amount of errors that we're seeing? Is there a drop in errors? Is there an increase? Can we compare that against other clusters? And using some of the powerful expressions that we showed earlier on through Loki and LogQL, we can do that in such a simple way. And with external labels being applied, it means that we can select and know where those logs came from. The second really important part of our goal this year is for supply chain security. And as part of the security element, we need the observability. So it's great to have something like Aquasec, Falco, Sneaker, any of these solutions to look at your images, look at your running pods and containers. But if you're not actually alerting on that, it's really difficult. And the alerts sometimes can be difficult to manage, difficult to write in Prometheus rules. And so therefore, again, we can take a simple sentence in Loki, and I can use that sentence. If that appears, that can trigger my alert, especially with Grafana alerts. So it's a really fantastic hand-in-hand solution for writing simplified alerts, especially around the supply chain observability. And the last thing that we're doing that's particularly exciting is adding additional synthetic monitoring into our tenant clusters. So I mentioned having application logs. I mentioned having the logs from the bare metal clusters. But what about we could actually pull the logs out from our tenant cluster nodes, and they could tell us, is there a problem far ahead of the Kubernetes API on the supercluster registering if a node has gone offline? imagine if a tenant node runs out of disk space, Loki would tell us ahead of time before Kubernetes API flagged after 5 minutes that node had gone down. So that's really what we're trying to do, is to really leverage that to the next level so that we can start to really get ahead of the curve so that we know about problems before they become problems.
So summarizing, in this presentation, we showed you what Loki actually is. What are the different components that go into setting up Loki? And how would you get started using Loki and make the best out of it? And then we went over our key takeaways, our main learnings throughout the past months in our tricks with Loki. Now we have some time for Q&A, so we're going to join in just a second. Thank you so much for joining our presentation. And you can find us here with those Twitter handles on Twitter if you have any further questions.
Hello there.
Hello, everybody. Awesome. Thank you so much for joining. We have 4 questions right now. I'm just going to go ahead and read them one by one, and you can answer, Alex. So the first one is, what are your retention policies around your production infrastructure logs?
So we generate approximately 2 terabytes of logs a week from our production clusters. And so we retain them for approximately 14 days. And anything over that, we look to put into cold storage. At certain companies, there are compliance reasons, such as SOC 2, ISO 127001, where you have to retain production logs for 365 days. And, bearing that in mind, having a strategy for cold storage is really good. But yeah, typically speaking, it would be about 14 days, because any more than that, we find that it's an immense amount of storage cost on our object storage.
Okay, next question. How many Loki deployments are currently running at Sievo?
That's a really interesting question. So at the supercluster level, it's a 1-to-1 cardinality. So we're running 3 different regions right now, with I think a 4th coming up quite soon. So that would be 3 primary Loki distributions. Those distributions are tuned so that we would have between 3 and 5 ingesters, a multitude of queriers, several memcache deployments as well. So they typically look fairly homogeneous. However, we will tune them based on the throughput as well.
We have right now 4 more questions. The next one is, does Loki ingest all the logs, and or is there the ability to choose which logs to ingest versus index? And then thinking about comparison between Loki versus Datadog, Splunk, Elastic. What is the difference?
Yeah, that's a really interesting question. And I skipped it a little bit in the presentation, but you have separate data stores for the indexes versus the actual chunks of Loki. And so, yes, you can index logs and you can isolate to a degree. However, there's a little bit of post-processing you need to do for that. In terms of, can you select the logs? Yes, this is one of the nice things, is that you use scrape configs. You can add annotations and labels to those logs as well. So I can simply select a log path, such as the Kubernetes audit log that would be available on a node or on a cluster, and then Prometheus will go off and grab that. Something else that Prometheus uses that's really interesting is the fs notifier and file watch commands at the operating system level, so that it can then pick out the latest changes from those files as well. So really think of it more as an active tail.
Next question. We mentioned Tempo in combination with Loki. Are we currently using Tempo, and what's the process of getting them both linked together? And could we share any data points around trace volumes?
So we are actually using we're using Grafana for our UX. We're using Loki for our logging solution, and we're using Jaeger tracing in our production environments. However, we're very keen to migrate to Tempo. Tempo has gone through a graduation recently, and there's a whole slew of new features that we're excited to integrate. One of which is the searchability of Tempo logs, which wasn't actually something we could use previously. And as soon as we've got that update, we'll get it in place. In terms of trace volume, our traces are actually being emitted from our operators. And in Civo, we have between, I think it's 5 and 8 primary operators that manage our clusters. So those will create custom resource definitions, and they will then provision tenant clusters. And so those operators are creating between, I'd say, 1 and 5 RPS. So 1 and 5 requests per second, 1 and 5 spans per second, which is a fairly low volume. But what's interesting is that we're looking through reconciliation loops. And so the nesting of those traces goes quite deep. So the spans will go to quite a deep level of perhaps sort of 20 or 30 functions. I hope that answers the question.
Just heads up, there are a lot more questions, so maybe we can keep it shorter.
Sorry, yeah, I'll try and do a quick fire. Yeah, of course.
Okay. Are there any limitations storing and retaining logs?
Yes, it's expensive. It's expensive. Storing any kind of data set like logs is very expensive. However, Loki is probably the most cost-effective option I've seen so far, and I've worked with things like Splunk and other large-scale solutions. So it's the cost.
The next question is around the use of Prometheus. Now that we have Loki, we can have metric-like visualization plus alerting with Grafana. And then where does Prometheus fit into the mix of our?
Yeah, so logs are fantastic, but they're not the be-all and end-all because you don't emit metric or quantitative. All quantitative data doesn't come into a log, right? And logs are only as powerful or as useful as the person that implements them. So if the log isn't structured and it doesn't actually have, like a printf on the CPU use, you're not going to get that in the log. And so Prometheus still has its place as something that can effectively aggregate metrics that come in conjunction with logs. So I see them as complementary. They're not either or, right? I hope that answers the question.
Can cold storage logs be queried with Loki? So once you move your logs to cold storage after, I guess.
I mean, definitively what is cold storage? It's just transfer that is more expensive. I think you're probably talking specifically about AWS Glacier, and I couldn't give you an opinion. I don't want to say the wrong thing. We typically wouldn't access directly cold storage logs, so I'll refrain from making a comment on it. But yeah, cold storage is going to be, in a hyperscaler point of view, that's going to be higher transfer fee logs. It's not that they cannot be physically accessed. It's just that would you want to access them directly?
Next question is, I noticed no mention of a compactor component. I'm guessing custom retention featured in Loki 2.3. Is it not used at the moment?
That's a really interesting question. So we don't typically use the compactor in our configuration, and that is not for lack of wanting to use it. We use a compactor for our metrics. We use Thanos that does metric compaction. We don't use it for logging compaction purely because of our capacity to test these components out and take them to production. One of the things I was showing in the demo is the distributed Loki microservice configuration out of the box was extremely persuasive in being like, let's get up and running. All of the additional components such as mem caching and everything else, we've had to go through and assess. But yeah, as Loki matures, as we come along, we'll start looking at other components such as compactor. And as my previous comment around log costs, this sort of stuff could really help us out.
Next question is, have you tested Cassandra versus Memcache for caching performance?
That's a really good question. Typically, Memcache will have a higher performance than Cassandra, and there's some prior art to that. I can't give you figures right now. Cassandra, though, would beat Memcache in durability because of the replication mechanisms within Cassandra. So it's a trade-off, right? Memcache will give you a lower latency, but Cassandra gives you a higher durability and reliability. So there's a trade-off there.
Are you dealing with multi-tenancy? If so, how?
Yeah, so that's interesting. So our logging from Loki is for the supercluster. Our tenants, our customers, live inside that supercluster, inside of isolated virtual machines, and we do not scrape their logs, right? So we're not looking at the kubelet logs inside of the tenant clusters. If we were to do so, and I've entertained the idea, it would involve a vast level of relabeling because you would need to make the logs relevant and searchable. So you would effectively need something like Promtail with a relabeling mechanism at the individual level. But no, to answer your question, we don't do that at the moment. We just look at the supercluster logs.
Have you experimented with recording rules in Loki?
No, we haven't really looked at that at all, to be honest.
And the last question is, what tool have you used for the graphics?
Oh, that's Excalibur. And I think I need to start taking royalties on how much I use those in conference talks. Although, did we use Excalibur or did we use the Grafana template?
So we partially used Excalibur, we partially used the Grafana templates that were provided to us.
Kudos to the team. Yeah, the great
to
graphics.
this amazing template, exactly. That made it really easy to make it look good. Yeah, and that's it. That's all the questions that we got. Awesome. Thank you so much for joining.
Thank you, everybody.